2.10 is the mathematical modeling of variation. So we're going to talk about direct variation, inverse variation, all of that today, okay? Most of this you guys have heard about. You might have heard, haven't seen the nth power variation, so that might be a little bit new to you, okay? The first one is just the table. This kind of looking at a scatter plot with correlation, that kind of stuff with it. Okay, the table shows the population Y in millions of the United States from 2008 through 2015. A linear model that represents the data is Y equals 2.43T plus 284.9, where T is between 8 and 15, which is our years. Okay, since we're starting 2008 to 2050, that's why that restriction's there, okay? Plot the actual data on a model on the same graph. How closely does the model represent the data? Okay, so could I graph each one of these points on a scatter plot? Yeah, where the year is my X and the population is my Y, okay? Then could you graph this linear function? Yeah, because we have a y-intercept and we have a slope, correct? Now, that's going to be a little more challenging, so I'm not going to make us do that by hand. But we can go ahead and tell how closely the model represents the data by plugging each one of these years in and seeing how close the population is between the two. So could we do that? Yeah, so go ahead and pull out a calculator if you have one, okay? If not, I know you guys have your phones right now. Go ahead and use your phone, okay? So we're just plugging in numbers. Oops. All right. So let's first start with 8. Okay, remember our years, we're not plugging in actually 2008. We're just plugging in 8 to represent that. 2009 would be 9. Okay. So now I'm going to go ahead and plug in y equals 2.43 times 8 and add that to 284.9. And what do we get? So 304.34. And we'll go ahead and round to the 10th because all of those are to the 10th. So far, that's pretty close, isn't it? Yeah, so let's go ahead and try now year 9. So we're going to change the 8 and make it now a 9. And what do we get there? 306.8. Good. Good. What do you guys notice about that one? That's the exact same point, isn't it? Yeah. What about for 2010, what would I use? I changed the 9 to 10, right? Which we get 309.2. All right, go ahead and do the rest of them. 2011, 2012, 2013. What do we get? What did you guys notice about all of those values that we plugged in? They're very, very close, right? So how well does that linear model represent that scatter plot? Very closely, right? Okay. So if we had graphing calculators, we could actually graph all of that on their points We can find the line of regression there, but because we don't, we're just going to kind of go in that sense of it. You guys do know about Desmos, right? Desmos.com. You can actually pull up a graphing calculator online, and you could graph those points and the actual lines on there to find intersections and that kind of stuff, just so you know. Okay. All righty, let's move on. Direct variation now. Okay, there are two basic types of linear models. Okay, the first one we kind of already looked at was y equals mx plus 6, or plus 6 plus b plus b. Okay, that is your slope-intercept form. Okay, and with that, b can't equal 0. Okay, for our slope-intercept form. And the reason why b can't be 0, because then when b is 0, that's actually our direct variation formula. Okay, y equals kx. The only thing different is obviously your y-intercept is always 0, so direct variation will go through the origin, okay? And instead of using m, they use k. That's it, okay? But k still represents kind of that slope in that sense, okay? With this, okay, the simpler model, in the simpler model, y will vary directly as x, okay? Varies directly, okay? Or is also directly proportional to x. So we can say y varies directly to x, or it varies, or it's directly proportional to x. Okay, so either way in that, it's the same thing. The k, okay, is the constant of variation, which is also like our slope, okay, but k is known as that constant of variation, or is a constant of proportionality. Okay, so same idea in that sense, okay? So the y-intercept is 0, and your k, your slope, is the constant of variation or the constant of proportionality, okay? All right, in Pennsylvania, the state income tax is directly proportional to gross income, okay? So my state income tax is directly proportional to my gross income. So my state income tax is my y, and the gross income will be my x, because we always say that y varies directly to x, okay? So my state income tax is my y, and my gross income is my x. You work in Pennsylvania, and your state income tax deduction is $46.05 for the grossly month income of $1,500. Find the mathematical model that gives Penn State income tax in terms of gross income, okay? So since this is directly proportional, we're looking at the equation of y equals kx, right? So our mathematical model is going to be y equals something x. We have to find the k. The k is our value, right? Did they give us some kind of information within the story problem? Yeah, they gave us that our state income tax is $46.05, okay? Well, the state income tax, what does that represent? Does that represent my y or my x? My y. So could I plug that 4605 in for my y? Yeah. My gross monthly income is $1,500. So that $1,500 is actually going to be plugged into what? My x. And then do we know what k is? No. But now can we find our k to be able to plug it into our function? Yeah. And how would I find my k? Divide by 1,500. So k would represent what? Or equal what? 0.0307, right? So now what would my mathematical model what would be my mathematical model here? Y equals, what's my K? 0.0307x. That would represent my Pennsylvania income tax in terms of your gross income. Does that make sense to you guys? So this K actually represents kind of my rate, my income tax rate. What would that be as a percentage? Yeah, what would that be as a percent? 3%, yep. All right. All right, next one. Okay, so we also have direct variation as an nth power. Okay, so we have exponents here, right? Okay, in this case, it says y will vary directly as the nth power of x. So y is directly proportional to the nth power of x. So the only thing that changes in our formula now, we're still going to have y equals kx, but x is to the nth power. So we need y equals k times x to the nth power here, okay? So again, how do we know if it's different between direct variation or the direct variation to the nth power? They're going to tell us a power. It's going to say like squared, cubed, things like that, okay? All right, so example 4. The distance a ball rolls down an inclined plane is directly proportional to the square of the time it rolls, okay? So the distance a ball rolled as inclined plane, okay? So the distance the ball rolls is going to be represented as what? It's my y, right? Remember, because y varies directly proportional, right? Okay, y varies. Y always starts first, okay? Now, to the square of the time it rolls. So the square of the time it rolls would be what? My x, right? But now it's a square, so what does that mean? X squared, yep. So that's how we know it's direct proportional, okay, to the nth power because it said the square of it, of the time, okay? All right. Write an equation relating the distance traveled to the time, okay? So again, my y is the distance, okay, in feet, okay? So am I looking at here? Okay, during the first second, the ball rolls 8 feet, okay? So my ball rolls 8 feet. So that's my distance, right? So my distance would equal 8, and my distance is my y, isn't it? You guys okay with that? My x is my time, right? My x is my time. And what is my time? During the first second. So what would my time be? What would my time be? The first second. Nathan? 1, yeah, would be 1, okay? Directly proportional, okay? So now, to write the equation, remember, it's y equals k to the x, and in this case would be squared, right? Okay, would be squared here. Now, we have to find what to be able to write the equation? The k, right? We need to find that constant of variation. So let's find that k. So my y is 8. K we don't know. And what is my x? 1 squared, right? So what would k equal? Would be equal to 8, right? Because 1 squared is 1, divide by 1. So my k is 8. Okay. Now, since we're relating distance to time, I'm not going to use y and x. I'm going to use d and t. Is that okay? All right. So my equation now would be, my y would be d, equals, what is my K? What's my constant of variation? 8. And instead of X, I'm going to use T squared. And there's your equation. So if you notice, every time we're writing the equation, we always have to find what? The K. Okay, and then always plug in your X and your Y, leave it there. Okay, now part B, how far does the ball roll during the first 3 seconds? There should be an S there. So how would I figure out the distance? Well, do I have an equation? Yeah. And 3 seconds, what does that 3 represent? Does that represent my D or my T? My T. So if T equals 3, can I find how far, which is my distance? Yeah. So my distance, we don't know, but I have 8 times, what's my time? 3 squared. All right. Now what's 3 squared? 9. And 9 times 8? 2. So my distance would be 72 what? Feet. There you go. And you just did it. Okay with that? All right. Inverse variation. Hey, have we talked about inverses? Yeah. To find inverses, we split the X and the Y and we solve, right? I'm going to go ahead and do that for you. All right. The equation would be Y equals K over X. Right? K over X. Which makes sense because when we had direct variation, it was Y equals KX. Well, what's the opposite of multiplication? Division. That's why it's dividing here. Okay. How do we know if we're going to use this formula? It's going to say varies inversely or inversely proportional to it. Okay. All right. So a company has found that the demand of one of its products varies inversely. So varies inversely as the price of the product. Okay. So a company has found that the demand of its product. So my demand represents what? What variable? Y. Varies inversely as the price. And what's my price? The X, right? Okay. When the price is $6.25, the demand is 400 units. Approximate the demand when the price is $5.74. Okay. So the first thing we need to do is find my what? K. We have to find the K. All right. So my equation again is Y equals K over X. All right. Remember, Y is my demand and my X is my price. So when it says when the price is $6.25, so where would $6.25 go? In the Y or the X? The X. So $6.25 here. Okay, we're trying to find. The demand is 400, so the 400 goes in the Y. Okay. Now, how do I find K? Multiply, so my K is 2,500. Good. So what would my equation be? My Y is my demand, right? So my demand would equal, what's my K? 2,500 over my X, which is price. So we'll just label it D and P so we kind of have an idea. Okay, so there's your equation. Now, approximate the demand when my price is $5.75. So where will the $5.75 go? In the P, right? So we have 2,500 divided by $5.75. So what is my demand? Roughly 435 units. There you go. So if you notice, inversely says very inversely, varies directly to to the square of something, to the cube of something, okay? That kind of determines which equation you're going to use, okay? All right. And then the last one, nope, we got to go some more. All right, the combined variation is some applications of variations will involve problems with both direct and inverse variations. Okay, those are called our combined variations. So let's kind of look at this here. Okay, so we're going to look at an example. Okay. A gas law states that the volume of the enclosed gas varies inversely as the pressure and directly as the temperature. Okay, it's kind of a little confusing there, right? Okay, so let's kind of read again. Volume varies inversely. Okay, so my volume will still be represented as what? My Y. Okay, so my volume is my Y. And every equation is always Y equals, right? All right. It varies inversely to the pressure. Okay. So the pressure would be my X, right? And if it varies inversely, what was my equation? It was K, was it KX or K divided by X? K divided by X. So we're going to have K over, what's my pressure? My X, right? So I'll put P for my X, if you guys are okay with that. But directly as temperature. So what would I do with that K? Would I divide by the temperature or multiply by the temperature? If it's varying directly. Multiplying, right? Directly means multiplication. So inversely is dividing by X. Directly is times by X, right? So I'm going to take my K and multiply it by my temperature. Okay, you guys okay with that? Now, we actually have to find the K to be able to write the equation, right? All right, so let's kind of see what they give us. The pressure of the gas is 0.75 kilograms. So where will that go? The pressure of the gas is 0.75. So where will that go? In the X, which is the P, right? In the P. Okay, so pressure. That's why I kind of changed the letters a little bit. Okay. When the temperature is 294, so where will 294 go? In the T, 294. And my volume is 8,000, so equals 8,000. Now, can we solve for this? Yeah, I would take 8,000 times 0.75, and then what would I do with that? Divide by 294, right? So I take 8,000 times 0.75, and then I divide it by 294. Will equal my K. And what do you guys get for your K? Point what? 49? 41? What you guys got? 0.41? Yeah, okay. All right. Now, can we write our equation? Yeah. We're just going to replace K with, so we have volume equals 0.41 times my temperature divided by my, huh? Oh, 20. Okay, sorry. 20. Is that better? That's a 2. 20. Sorry. All right, so I left it as a fraction. That's why I didn't know what the decimal was. So either way, now, can we find the pressure when the temperature is 300 and the volume is 7,000? Yeah. Where would this 300 go? In the T, yep. And where would those 7,000 go? In the V. So I have 7,000 equals 1,000 times my temperature, which is 300, over 49p. And now, can we solve that? Now, you can use the decimal one. It doesn't matter, okay? I just have my work. I have the fraction, so I just left it as a fraction, okay? So in this case, I would take 7,000 times 49p equals 1,000 times 300, right? And then what? That's 300. Then I would divide by whatever 7,000 times 49 was. So those cancel. So we would get our pressure would equal roughly 0.87 kilograms per centimeters. And that's just solving an equation. Are you guys okay with that? Okay. I don't actually have the math through that. Okay. Any questions? All right. Then our last one here is our joint variation. What do you guys notice is different? Z varies jointly as X and Y. What's different from the other ones we just did? Z is jointly proportional to X and Y. What's different about the other ones? Remember, Y varies directly as X. Y is directly proportional to X. Y varies inversely as X. What's different here? Huh? I can't understand. It says jointly. Yep, that's something different. What else? Nathan? Right, we're not looking at just Y varies directly to X. We have 3 letters now, don't we? We have 3 unknowns. Z varies jointly as X and Y. Okay, so now we're starting with Z equals, and this one's kind of nice because it is almost exactly like direct variation, where you have KX, but you don't have just KX, you have KX, Y here. Okay, so you have KX and Y here. Okay. The most common one with joint variation is our simple interest. You guys have learned simple interest before, haven't you? I equals PRT, right? It's kind of like the same idea here, okay? The simple interest for an investment is jointly proportional, okay? So simple interest is jointly proportional. So the simple interest represents what letter? What letter? Z. Z. To time and principal. So time and principal. So my X and my Y. After 1 quarter is 3 months. The interest of the principal is 5,000. Of 5,000 is $43.75. Write an equation relating interest, principal, and time. Okay. So we're looking at Z equals KXY, right? Where Z is represented as what? Our interest. K we'll have to figure out here. X is my time and Y is my principal, right? To be able to write this equation, we have to find what? What K is, right? So let's plug in our information. 1 quarter is 3 months. So remember, time is always in years. So 1 quarter is represented as how much of a year? 1/4, right? So my T is equal to 1/4. Okay, so I'm going to start with that, 1/4. Principal is 5,000. So that goes in the P, nothing we have to do there. K we don't know. And my interest is $43.75. So now, can we go ahead and solve this? Yeah, can you figure out what 1/4 of 5,000 is? Yeah, And then how would I move that to the other side? When I divide it? Yeah. So what do you get for your K? So my K represents our interest rate, so you guys know, okay? So K is my interest rate. So what did you guys get as for your K? 0.035, good. So that's roughly what, 3.5%, just so you know. Okay, so what would my equation be? I equals, what's my K? 0.035, and then times T times P. So there's your equation. Now, can I find my interest after 3/4? 3/4 represents what of a year? 3/4. So can I find I when my T is 3/4? Yeah, because does my principal ever change? Does my principal change? No, because my principal is what my starting amount is. How much did I start in the account? How much was my loan? Okay, that never changes. So let's go ahead and plug it in. I equals 0.035 times T. What's my T? 3/4 times my principal, which is 5,000. So after 9 months, how much is my interest? 3/4 would be 9 months, right? What is my interest? It's money, right? Good. So after 9 months, I just gained $131.25. All right. And that is everything here. Okay. Is there any questions with that? All right. So a couple things. Your homework is listed there for you. Okay. I'm going to stop sharing if you guys are